Let's start by looking at exactly what a chemical reaction is. First of all, chemical reactions always produce a new substance. They often release large amounts of energy, but most importantly, a chemical change, unlike most physical changes, cannot be changed back. Let's have a look at some that are close to home.
Just in time. Perfect. Another chemical reaction has just happened here.
Chemical reactions are useful in cooking. They help improve the taste of food. Cooking and chemistry have quite a bit in common. The starting materials in a chemical reaction are called the reactants. These react with each other to form a completely new substance, the product.
As you can see, products have very different properties to the reactants. This cake is a lot firmer, tastes a lot nicer than the individual reactants. It's a different colour too.
Not all chemical reactions need heat energy to make them happen. Take some bicarbonate of soda, add a little vinegar, and watch. It's another chemical reaction. This time, one of the products is a gas, enough to inflate a balloon.
Let's take a closer look at another chemical reaction. What happens when we add the metal iron, which is in powdered form, to yellow powdered sulfur? The iron is a metal, and as we can see, is magnetic. The two reactants are mixed together and then heated. When the substance cools, we have a black solid called iron sulfide, a new substance which we call the product, and we can test. It's no longer magnetic. A chemical reaction has taken place because we started off with two elements, iron and sulfur, and ended up with a compound, iron sulfide, which looks and behaves very differently from the original reactants. So you should know that chemical reactions are made up of reactants, which react together to produce new substances called products. To summarize the reaction of iron and sulfur, we can also write a word equation for it. The reactants are iron and sulfur. They're put on the left-hand side of the equation, and the product, iron sulfide, appears on the right-hand side of the equation. So iron plus sulfur equals iron sulfide. Another category of reactions is decomposition reactions. These are chemical reactions where a compound is broken down into simpler substances. This can be done by heating using a catalyst or by electricity. So when copper carbonate is heated, it breaks down into copper oxide and carbon dioxide.
Oh, that was quick. There we have it. Copper carbonate to copper oxide.
Many metals exist naturally in the ground as oxides. This is aluminium oxide, bauxite. This is iron oxide, and this is copper oxide. Now, they don't look much like the pure metal because they are compounds of the metal and oxygen. To release the pure metal, the oxygen has to be removed, and this is done by thermal decomposition.
This yellow powder is lead oxide. It looks nothing like the metal lead, does it? It's impossible to separate the lead from the oxygen by sieving or shaking. Instead, I need to heat it with carbon, the black powder, to produce a chemical reaction. Eventually, it releases tiny drops of molten metal, pure lead.
And we can write a word equation for this reaction. Lead oxide plus carbon makes lead plus carbon dioxide. The burning of fuels, and these are called combustion reactions, as they release large quantities of thermal energy, heat energy. All fuels, like gas, wood, coal and wax, burn in oxygen, producing heat and light, and waste products, carbon dioxide and water. And it's this heat and light that can be controlled and used to provide warmth for things like cooking and for the generation of electricity. Let's look more closely at the burning of a fuel.
Fire is a chemical reaction. The flame you see is what comes out of this chemical reaction. Gas is so hot that they're glowing. The chemical reaction happened between fuel, natural gas, and oxygen from the air. But to get the reaction going, it also took heat energy. These are the three things you need for fire: a fuel, oxygen, and heat energy. The chemical reaction produces more heat, energy which is useful. But useful not just to us, it also keeps this reaction going, so long as the fuel and oxygen keep on coming.
So, thermal decomposition is a chemical reaction where a compound is broken down into much simpler substances.